everyone. I'm really excited to talk to you tonight. I hope you're excited as I am about experimentation. Like we said earlier, sometimes it can feel like magic, but it really is just the magic of math and, being able to really be data-driven. And I think that as we get more AI in the world and it's writing more code and it's doing more things, it becomes even more important to measure things and have guidelines in place to make sure that AI isn't getting out of control and it's still working for us instead of working against us. So with that in mind, I'm really excited to talk about 10 experiments to run before you die. But before we dive into that, I'd love to talk about one of my favorite experimentation quotes, and it's that all models are wrong, but some are useful. And I've found that this is a really controversial quote. A lot of people don't like it when I talk about everything being wrong, but sometimes helpful. But I think that when we dig deeper into what that means, what we're really saying with this is that all models have uncertainty in what we're dealing with, and we're gonna always be making assumptions. So we're always kind of using that trade-off to think about what we're trying to understand, what assumptions are we willing to make, and in turn, how precise can our conclusions be. You have to make more and more assumptions to get tighter conclusions, but it can be really powerful when you kind of use the right mix of the two. And then when we're talking about models, that means we're also talking about causal inference methodologies. And within causal inference methodologies, I really like experiments, but there's a lot in our toolkit other than experiments, and I think that it just kind of works more on that trade-off of needing more assumptions than maybe an experiment where randomization does a lot of the heavy lifting. And honestly, I get to be a little lazy, right? Because in expectation, a lot of things kind of just work. And obviously that's an assumption that, we're relying on in and of itself. But it's kind of a shared assumption that we're really willing to build a lot off of. When we're talking about experimentation versus other forms of causal inference, I think that it is nice to avoid assumptions like, in diff and diff, we're assuming parallel trends. I think the first time I heard about that, I was like, is that allowed? We can just assume they're parallel? So it's nice that with randomization, we're not making assumptions about the underlying data. We're using things like the temporal limit theorem to know that something about their mean. And we have kind of this well-established branch of science that we can use to really understand our business outcomes and make decisions with kind of this shared language of experimentation. It can be really powerful. So the next part of this talk really is 10 experiments. I'm going to go through 3 different types. The basic experiments that probably everyone here is or has been using, which is not to say that we should blow past them. I think they're some of the most important types of experimentation that we can talk about because they're so useful in the vast majority of cases. We'll also talk about some hard questions that we can answer through tweaking our experimental design and our approach, and what we can do when we have those hard questions, and kind of understanding the context and using something that fits the situation. And then we'll move on to jet fuel, which is just a way of saying what helps us move fast? What's going to let us speed up this process, and what can we do in our experimental design to make sure that we're able to make decisions quickly and actually realize that business impact that we're learning about. All right, into basic experiments. The first one I wanted to talk about is the standard growth A/B test. You can tell that I'm not a marketer by any means by this slide, but this is kind of an example of 3 different possible treatments for a sign-up prompt, right? And I can measure that outcome in terms of hey, how many people sign up, how many people move through my, funnel that I've established. And it's a really powerful tool to actually get any adoption of a product that you might be working on, and maybe acquire some of those users that you would like to have. When we're thinking about measuring this growth, we have some of the ones I've already talked about: sign-up rate, a checkout flow, and the number of visitors. But I think it's important to note that this is also missing stuff, right? What are some ideas of metrics that other folks in the audience might have? Any takers? Yeah, what about you? Monthly active users, yeah, looking more long-term about continued usage. Any other ideas?
Sure.
Yeah.
Average order value.
Average order value, talking about every interaction they have. Are they, getting value from that? Yeah, that makes sense.
Time to make decisions.
Time to make decision. Are they wasting their time being confused about, like, do I need to click this button or that button? Why do I need to enter my address 5 times? Yeah, exactly. No, those are all, oh, yeah.
Generally, website analytics, we do check engagement.
Yeah, engagement, web analytics, there's kind of that standard formula. Yeah, I'm glad you mentioned that because there are a lot of standard options, but ultimately it does matter like what's specific to your product. I think a lot of times, notably like a Facebook would use like time spent is like a great measurement of how well their product is working. But if you look at something like Google, time spent on Google search would probably be a bad thing to like say, hey, we love having time spent on our search app, which means people aren't getting what they want. So yeah, depending on the context, but there's a lot of good rules of thumbs. And it's so much richer than just like, hey, did someone click on this or not? Did someone like my clickbaity get 1/millionth of a Bitcoin? No one? Yeah, I think just having a really rich set of metrics is super important for that. I also wanted to talk about standard A/B product tests. That's anything within your product that people are already using that's actually going to help you retain those users. There's no point pouring water into a leaky bucket, right? And so this is going to be the bread and butter for a lot of data scientists. And PMs and engineers. Experimentation really is a team sport. So everyone's kind of working on making that product better. And, this kind of notification test is an example here. There are things that you can do that are really helpful. People understand when they come back what they want. But you can obviously go too far too and have really noisy notifications that you need to know when things are going poorly, not just when they're going well. And so experimentation isn't just a tool to say like, hey, I built this really great feature, let's ship it. It also helps us understand and learn from when we may have missed the mark. Like I mentioned earlier, these are really commonplace, but that doesn't mean that they're simple, even if they're something that we're all using. It's not just UI changes. There are tons of different things that you can experiment on, including ranking long-term outcomes, infrastructure and performance. If you're a Statsig user, you've actually been in one of my performance experiments on the Metrics Explorer query speed. And so that's been really helpful when, in the back end, complex things are happening and we need to make decisions that are best for different customers based on that. You can use different populations. When I was running that experiment, I was using each query itself as an independent unit to just measure latency in different circumstances. You can also use a mix of users' temporary or permanent attributes, as well as different targeting based on who you think will be most impacted by a change and who you want to offer something to, like a discount code that maybe you're only sending to people who haven't visited in a while. Targeting can be really powerful. Like I mentioned earlier, it's really great at catching when you don't actually have something helpful, and it helps you not mess up when you're trying something that doesn't work, or when you have a great idea, but maybe the implementation misses the mark. We've had a customer implement something that they thought was a no-brainer, but then found a bug in some corner of a certain browser on a certain phone type. It was actually completely screwing up those results, and so they found a really niche bug in that situation. And then just understanding measurement is not one size fits all. We talked about different things to measure the hypothetical click-through test, but understanding that different metrics are good at different times. I have another test up here. I've heard that we're all practicing to be mentalists. Can anyone read my mind and tell me what this experiment is? Any ideas? It's hard to read. I'm so sorry. I can start reading it out. It's saying that there's an average latency measure as the primary metric. We've got revenue as that first secondary metric, and then visitors, and then page views. A conversion test, yeah, that's a good guess. Any other guesses? I'll give you the answer. It was a trick question. It's an AA test. It's a really cherry-picked, messed up AA test, but it is an AA test. So an AA test is going to be when we're not actually making a change or we're just doing randomization. And I think that can be really powerful because that can help you understand, is there something fundamentally wrong with your randomization methodology? Is there something where you're triggering something that shouldn't be changing anything, but actually is because of how you're, targeting something? There are a bunch of different, potential edge cases that you can catch when you're implementing something in a new way by using an AA test. I think another benefit of it is to just look at an AA test and understand that false positives kind of happen a lot, not this frequently, that's very cherry picked, but that in expectation, if you're using a 95% confidence interval, 5% of the time you're looking at a false positive, and just understanding that as a really real risk when you're doing experimentation. That's a great segue into holdouts because that helps you know that if there's a false positive, you have kind of a second check, right? It might be part of a larger hold tout. You might have a feature level backtest. There's so many ways to holdouts. This is actually from an Etsy blog about how they run their holdout methodology. It's a little different from what we do for ours, but there's a lot that you can do with holdouts that are just really powerful for double checking your work, looking at long-term effects, and just understanding how some feature changes might work together and either be synergistic or antagonistic, and understand the benefit of your experimentation program as a whole. One other helpful thing is you can look at the time series view of this, and you can kind of see it starts as an AA test, right? If there's no changes between your holdout and your what you're serving other users, there's no difference. But then over time, as you might be adding more and more features to be either delivered to most of your users or held out from a certain set of users, you can see this kind of compounds over time from nothing. This is also a really powerful effect for if you see your holdout doing better than your control group, which is the majority of your users. It's also really cool to see if you run. Well, cool to see. It's bad, but it is an interesting effect when you have an experiment that's negatively impacting metrics that you haven't even shipped yet, but because you're testing it, there's a real cost to your users who are experiencing that negative experience. And it can be a real wake-up call to kill that experiment early because it's doing real harm. We can move on to hard questions. When there are certain when there are certain circumstances where you think, I don't think I can run an experiment at all. This is breaking a fundamental rule. One of those is when there's interference. That's definitely breaking SUDVA. I rely on that all the time to do experiments. What do you mean there's interference or network effects? So this is the example of a billboard campaign, shout out to our design team who made that incredible billboard. Sorry for shilling super hard, but basically when you have the treatment of this kind of out-of-home marketing type moment, I can't just look at users as units and be oh, they for sure saw the billboard and that's why they bought this. But what I can do is kind of use other techniques to fill in the gaps. One of those such techniques is using a synthetic control as the test. So a great example for what this would be doing is, let's say that I'm running a test in Seattle, and I'm oh, Seattle's if you mix SF, Portland, and Boston all together. Then if I look at those cities that I say, oh, if you mix them together, that's what Seattle is. If I make a change in Seattle, but use a model to produce that counterfactual for what Seattle should look like in absence of that treatment, then I can have this synthetic control test set up. There are a lot of really cool libraries like geotesting from Meta that are able to help you do this really quickly. And then also Statsig offers it as well. But basically, it's great to be able to use a synthetic control test when you need to kind of compare things to a counterfactual of them. It's really powerful instead of a pre-post comparison where you're all my Black Friday campaigns are incredible and people buy a lot of stuff. ignore the fact that everything's on sale. It's totally my marketing, because you're also comparing to other places where that same temporal effect is happening. And so that kind of model approach can be really powerful when you might have those temporal fluctuations that are really impactful. I think another great way to approach this is switchbacks. I think switchbacks have become pretty well known in the rideshare use case, but it's really important in any marketplace. The reason that rideshares it's so useful in is because it's kind of this really quick interaction that you're having with the app, and that's really specifically helpful in switchbacks, where you're kind of turning the treatment on and off for a particular marketplace or segment of that. So like, often with these ride shares thing, they'll target city by city and do that independently of each other, but turn it on and off for each city, right? Because your interaction is for a fixed time in that kind of app, you either decide to take that ride or not. You can kind of assign it to whichever treatment you were receiving at that time. And it doesn't have this longer term effect of like, oh, we'd have to run the switchback for like 2 days at a time. That's crazy. You can do them pretty quickly and have these kind of burn-in, burn-out periods that help you avoid any kind of bleed over from the previous treatment into what you're recording. Another really cool, hard question that you can deal with is, okay, I'm running all these experiments. I'm making the right decisions at the end of the experiment, but I kind of need to know beforehand, like, what's the ROI of investing engineering time into this kind of product? And I think that's where an elasticity test can be really powerful, because I know that if I decrease latency, that's usually a good thing. I want to do that. But what's the trade-off between, hey, I only have finite engineering time, they could be building features, they could be doing other things and not working on the latency. So an elasticity test is really powerful for me to understand that trade-off. Like, what do I get for that engineering time invested? Kind of a controversial way to do an elasticity test is by combining that with a regression, where you're purposefully increasing the latency and kind of making the experience worse, and understanding the impacts of that. It's a really controversial methodology. I know that there are some companies that just say, we don't do them, full stop. Why would we make something worse for our customers on purpose? That's crazy. But I think that it can be a really powerful tool, and it just speaks to that trade-off between, like, this is a really powerful for learning, but you could end up, losing all your customers if you were constantly giving everyone regressions that weren't necessary and not giving them the best product they could have. You could really lose user trust. That brings us to the final part where we talk about jet fuel, things that are going to help you run experiments even faster than you might be already. One of my favorite methodologies is SPRT. I feel like when you're talking about, normal frequentist testing, you have kind of the idea of like, nothing changed, but you're making the assumption that nothing's changing. So it's a bit of this like circular, I assumed something, trying to disprove it, and I didn't get to disprove it. That's kind of a bummer. But with SPRT, it's a methodology that allows you to have the negative case of that, where you have this threshold that you're willing to accept that nothing has changed. So especially when you have guardrail metrics, like, our secondary metrics are kind of examples of what might be guardrail metrics that you want to not change with your experiment. You can have that case where you have this conclusion that, like, there is no difference, instead of kind of a more, like, vibes-based frequentist where you don't actually get that indication. Another great way to make decisions more quickly is less about making that final decision more quickly, but more about mitigating the loss of sending people to like a bad experiment arm. What's kind of happening here is that we have this, cumulative success rate over time, and a typo at the bottom. Oh, no. And the probability that this variant is the best over the time. So we figure out pretty quickly that the circle variant of this one, the red line, is pretty awful, pretty garbage. A way that we can make that helpful is also making the assignment rate for a variant the probability that it's the best variant over time. This is a really straightforward example of a bandit approach. It's Thompson sampling. But even the most basic version of this can be really, really powerful when you look at like the loss function that's produced from it. Finally, another quick way that's really specialized, and one of the things that I think is really cool when we talk about AI and experimentation is an interleaving experiment, where you're taking traditionally search results and you're interleaving their results. But I know that in AI situations, when folks are testing different AI models or different system prompts, a really powerful thing they can do is give users 2 options of like, which version of this did you like better? And they'll select their preferred version. That's basically the n=1 version of an interleaving experiment. And so this seems like a really cool way for AI experiments to be kind of deciding like what's working with an AI feature. That is our 10 experiments, and I'd love to have everyone stand up if they're seated and raise your hand if you are not seated. Oh, this is a good cheat sheet slide. I should let people take a picture. I see a lot of cameras. This is a great cheat sheet. Yeah, these are my 10. But I would love some audience participation here. If you're in the back, please raise your hand. And if you're in the front, please stand up with me. I'd like to talk about how many of these experiments have you run? And if you've run 5 or fewer, please sit down. Okay, 7 or fewer, please sit down. And people in the back, I would love for you to raise your hands for this. So like raise your hands and then you can let your hand down once you haven't run that many experiments. Okay, 8 or fewer. Sit down if you've only done 8. But 8 is still a lot. Okay, have you done 9 of them or all 10?
Oh, I thought you were saying 8 overall.
What's that?
I thought you were saying 8 or 9.
Oh, sorry. People who have done 8 of them have just sat down. So 9 is what's left, but no one's done 9. So can the people who have done 8 stand up again or raise your hand again? If you've done 8, stand back up. 8. What's your favorite?
My favorite?
Yeah.
I think my favorite is bandits.
Okay, she likes bandits. Can you tell me a little bit about why you like bandits?
I think like if you have like multiple treatments and you have like different like huge user groups, and you kind of like just wanted to know like, oh, which treatment is actually better.
Yeah.
But like you can quickly get like the wing treatment instead of like you have to schedule a couple of them, you have to wait for all. I think it's fast to make a business decision, but you kind of like suffering like learning experience, like deep dive, like how exactly why it's happening. So I think that's like suffering, but you can have the business decision more quickly.
For those of you who may not have heard, what she was talking about was you get to make that decision really quickly, not just in allocating folks along the way, but if you have a really large field of options that you're trying to test out, you can move through those options really quickly and kind of come to that conclusion more quickly. The trade-off there that she mentioned is it's not necessarily as interpretable when you're looking at your experiment results and kind of trying to draw conclusions for future learnings from that. So that's really great. I do want to talk about also where experimentation fits into our overall toolkit for developing products, and in particular AI, as we come to more AI-generated things. Offline evals become more important because you can start testing things before you're actually shipping them to people, as well as online evals, where you're taking the inputs to your current model, running them in your new potential model, and evaluating that as well. Flags and canaries to get early signal of whether you should proceed with something. Online experiments, which we've been talking about for the vast majority of this presentation, and then also observability going forward and continuing to monitor something as it continues to be in use, and then just looking at all your metrics in one place over time and understanding that 360-degree view of what your product is doing, how it's interacting with an AI model or AI code as this generation of code and changes becomes easier. I think monitoring and understanding that product lifecycle becomes more and more important. With that in mind, I just want to thank you for your attention and hand things over to my colleague Zin and our amazing panelists.